Hi everybody, this is Indira, Assistant Professor of Institute of Aeronautical Engineering, Department of Mathematics. Today we are going to discuss the question bank questions of Fourier series, the last unit of linear algebra and calculus. Before going to the question bank questions, let us recapitulate what are the important points that we have to remember while solving the problems of Fourier series. To find out the expansion of the any function using Fourier series, one thing we need to remember the formula that is used to find out the Fourier expansion. Now, for the Fourier expansion of any function is given by f of x is equal to a naught by 2 plus summation an cos nx plus summation plus and summation we can take it at once into bn sine nx. This is a formula regarding the Fourier expansion. Here a naught, an and bn are called as a Fourier coefficients Now, what all we need to do is find out the three Fourier coefficients, that is a naught, an and bn values. So, if you find out a naught, an and bn, resubstitute in the f of x is equal to a naught by 2 plus summation an cos nx plus bn sin nx to give the Fourier expansion. That is the ultimate formula which we have to remember throughout while solving the problems in the Fourier series. Now, for this expansion is not valid for all type of functions. This expansion is valid for only one type of function, which is a periodic function. Now, what do you mean by a periodic function? A function is said to be periodic if it gives the same functional value at regular intervals of time, again and again. After moving to certain length of the interval, the functional value should be equal to same. For example, sine theta, cos theta, tan theta, all these are periodic functions. So these type of functions only we can able to get the Fourier expansion. Next, we can also say that the Fourier expansion is expressing the given function as a summation of the sine and cosine values, as a sum of sine and cosine values. So define a periodic function for a function f of x and give an example. The very first question. Now we'll see the very first question. So here the formula is same, but the interval will be different. We have number of intervals in the Fourier series. The first interval is 0 to 2 pi, and the second interval is minus pi to pi. And how to write the Fourier series in minus pi to pi, and L to minus L to L, that is arbitrary interval, and 0 to L. So all these four different types of intervals we have in the Fourier expansion. Apart from this, we have half range Fourier series, half range sine and cosine series also. So how to write the half range sine and cosine series? Even that also we have. And apart from this, it's better to know whether the function is even and odd function. So many varieties are different types of functions which can be used by only one expansion of the Fourier series, that is a naught by 2 plus summation n raises from 1 to infinity an cos nx plus bn sin nx. So four different intervals are there, two half range series are there, and two different even and odd functions. Totally 8 different types of functions we are going to face in the question bank also. So the very first question of part A, he asked that define a periodic function for the function f of x and give an example. A function is said to be periodic if the functional value is same after the regular interval of time. That is, f of x plus capital T should be equal to f of x. F of x plus capital T is equal to f of x. Then this T is called as a period. This T is called as a period. Here, for what is an example? Sine theta. What is the periodic value of sine theta, sine nx? That is pi by n. Next, define even and odd functions. How to define even and odd functions? When a function is said to be even, a function is said to be even, f of x is said to be even if f of minus x is equal to f of x. That means if you replace minus x in terms of x, we should get it as f of x. Then the function is said to be even. If f of minus x is equal to the next one, if f of minus x is equal to minus f of x, then the function is said to be odd function. Now here he has given state which of the following functions are even and odd. What we need to do? We need to put x is equal to minus x, and we have to find out whether we can take minus common or not. Minus x into sine minus x, sine minus theta is minus sine theta, so it becomes plus. Cos minus theta is cos theta, plus x square minus x whole square is nothing but x square, and cos h of minus x is nothing but cos hx. So here this is an even function. This is always even function. Now going to the next one, x cos hx. X, if you replace x by minus x, we are going to get cos h minus x is nothing but cos hx minus x cube minus 1 whole cube minus x we are going to get. And sine hx is nothing but sine h of minus x is sine hx. So if you take x as common here, we are going to get the function back. So this is nothing but the odd function. So it is better to write the condition when the function is said to be even and when the function is said to be odd also. Next, find the primitive periods of sine of the function sine 3x, tan 5x and secant 4x. The primitive periods of sine 3x is nothing but pi by 3 and tan 5x is nothing but pi by 5, and similarly we can give the primitive functions for secant 4x also. Next, write Euler's formula for the interval alpha to alpha. Euler's formulae are also called as a Fourier coefficients. There is another name for the Fourier coefficients called Euler's formula. So this formula can be given as a0 is equal to 1 by pi interval alpha to alpha plus 2 pi a0 f of x dx. This is the first formula. Similarly, and the second Euler's formula 1 by pi integral alpha to alpha plus 2 pi f of x cos nx dx, and if you replace by this by sine, we are going to get the third Euler's formula, that is 1 by pi integral alpha to alpha plus 2 pi f of x sine nx dx. So this is the third formula. So these are three are called as a Euler's formulae, right? Okay. Next, write the half range Fourier series. Write the half range Fourier series of 0 to L. What is the half range Fourier series? In a half range we have Fourier sine series and Fourier cosine series also. So the half range Fourier sine series can be given by f of x is equal to summation bn sine nx, and half range cosine series is given by a0 by 2 plus summation an cos nx dx in the interval 0 to L. So in the interval here in the half range sine series, the bn takes the value of 1 by L integral 0 to L 0 to L f of x sine n pi x by L dx, and in the cosine series a0 takes the value of 1 by L integral 0 to L f of x dx, and an takes the value of 1 by L integral 0 to L f of x into cos n pi x by L dx. So that is how we can give the half range sine and cosine series of the function. Write an examples of the periodic function. Just already in the first question we have referred that sine x and cos x or tan x are periodic functions. The periodic function, the better examples. Next, express f of x as pi square by 12 minus x square by 4 as a Fourier series in the interval minus pi to pi. So what is f of x? He has given x pi square by 12 minus x square by 4 he has given. Now what we need to write it, we have to find out the Fourier series. What is the expansion of Fourier series? F of x is equal to a naught by 2 plus summation a n cos nx plus b n sin nx. Now, what is a naught? Integral minus 1 by pi integral minus pi to pi f of x dx. What is f of x? Pi square by 12 minus x square by 4 into dx. So pi square by 12 is a constant. So pi square x by 12 we are going to get minus x to the power of 3 by 12 we are going to get, and where x has to be substituted minus pi, the upper limit, the lower limit minus pi, and upper limit pi to give the Fourier series. Now, next a n value. How to find out the a n value? A n value can be found out by the integral. A n is equal to, for the Fourier series, that is 1 by pi integral minus pi to pi minus pi to pi f of x cos nx dx. Cos n pi x dx. N pi x dx, or pi gets cancelled, therefore you can write it as cos nx dx. F of x is equal to pi square by 12 minus x square by 4, and which can be solved by using integration by parts integral of f into g, that is f into g1 minus f dash into g2 plus f double dash into g3, so on so forth. So like that you can find out our a n value. Going to the bn value. What is the bn value? Bn value is nothing but 1 by pi integral minus pi to pi f of x sin nx dx. So what we need to find it here, f of x again you substitute here, then we are going to get it as, that is pi integral of pi square by 12 minus x square by 4 sin nx dx. In using integration by parts and again applying the limits, we will get the bn value also. So after getting a naught, a n and b n value, we need to substitute these three values in the Fourier expansion, that is a naught by 12 plus summation n is equal to 1 to infinity a n cos nx plus b n sin nx to give the Fourier series expansion. Next, ninth equation. Write the Dirichlet conditions for the existence of the Fourier series of the function f of x in the interval alpha to alpha plus 2 pi. What are the Dirichlet conditions? These are the conditions which a function, minimally the function has to hold in order to apply the Fourier series to it. So what are the Dirichlet conditions? The first condition, it says that the function should be piecewise continuous, and that the function should be always continuous in the given interval. And next, it should be of exponential order. Second condition, it should be of exponential order. And then if these two conditions are satisfied, then the function is capable of applying the Fourier series. So these two conditions are called as the Dirichlet conditions. Next, and 10th one, if f of x is equal to x in minus pi to pi, find the Fourier coefficient a2. Find the Fourier coefficient. First, we need to find out the Fourier coefficient an. An can be found out by 1 by pi integral minus pi to pi f of x dx. F of x is nothing but x dx. So that is nothing but 1 by pi, and x is nothing but x square by 2. X square by 2 from 0 to, and it is an f of x, it's even an odd function, so that comes out to be 0. So a2 is equal to 0. So you can find out like this the 10th equation very easily. Now after finding out the an, we need to substitute n is equal to 2. After finding out the an, we need to substitute n is equal to 2 in the 10th equation. There is f of x is equal to x, what he has given. Going to the 11th question. What are the conditions for expansion of the function in the Fourier series? These conditions are nothing but the Dirichlet condition. The conditions that the function has to satisfy in order for applying Fourier series to it. So already we have discussed the Dirichlet conditions here. That is, the function should be piecewise continuous, and it should be of exponential order for the Fourier for applying the Fourier series. Next, 12th question: if f of x is an odd function and in the interval minus L to L, then what are the values of a naught and an? So if f of x is an odd function, then both a naught and an values both will become 0. We have only bn value. We need bn value. Suppose if the function is given which is an odd function like f of x is equal to x cube, then if you automatically find it out also, a naught and an both will reduces to 0. So instead of that, if you claim that if you verify that it is a odd function, then you can directly write that the Fourier coefficients a naught and an both will become both are zeros. So it reduces at time. We need to find out only one Fourier coefficient, that is bn value. Now, for next question, f of x is equal to x square in the interval minus L to L. Find the b1 value. B1 value. So minus what is a Fourier bn value that you can write it as? Bn value, here f of x is equal to x square. What is f of minus x is equal to? F of minus x is equal to minus f of f of x, because f of minus x is nothing but minus x whole square, which is nothing but x square. Therefore f of minus x is equal to f of x. Therefore it is an even function. For even function bn becomes 0, so directly you can write that bn is equal to 0 here without solving. Sometimes even we can solve it and also show that bn is equal to 0. Next is, what is the Fourier sine series for the function f of x is equal to x in the interval 0 to pi? What is the half range Fourier sine series? Summation bn sine nx. What is bn value? That is nothing but 1 by pi integral 0 to pi f of x sine nx dx. So here f of x is equal to x, we need to put x into sine x. So integration by parts, x into sine x, that is x into minus cos nx by n, minus derivation of x is nothing but 1, and integration of cos nx is nothing but minus sin nx by n square, and only two terms we will get, and applying the lower and the upper limit, that is the upper limit is pi and lower limit is 0, we are going to get the Fourier sine series. Okay, so like that, after finding out the bn value, you substitute in the summation of bn sine nx to give the expansion of the Fourier series, Fourier sine series. In terms of bn. So now going to the next one, what is a half range sine series for f of x is equal to e power x in the interval 0 to pi? Again, f of x is equal to e power x. So what is a half range sine series? F of x that is nothing but f of x is equal to summation bn sine nx. So here b is nothing but 1 by pi integral 0 to pi f of x sine nx dx. So f of x is e power x. So e power x into sine nx. And here both e power x and sine nx are both are continuously differentiable functions. So we can apply the reduction formulas to get the value, that is e power x, integral of e power x sine bx is nothing but e power ax by a square plus b square into a sine nx minus b cos nx. So the b cos bx. So like that you can apply the reduction formula to find out the integral of two continuous functions, and after finding out the b, again we have to substitute in bn to get the half range sine series for the 15th equation that we have in the part A. Going to the 16th question, define Fourier series of the function f of x in the interval c to c plus 2 pi. How to define the Fourier series of the function? Fourier series of the function is given by a0 by 2 plus summation an cos nx plus bn sin nx, where summation is holding for both the functions, second and third functions. So what is a0? A0 is given by 1 by pi integral c to c plus 2 pi f of x dx. and a naught an is nothing but 1 by pi integral c to c plus 2 pi f of x cos nx cos nx dx, and bn value is nothing but 1 by pi integral c to c plus 2 pi f of x into sine nx dx. So that is the Fourier series expansion or general Fourier series expansion for the 16th question. Next, define the Fourier series of the function f of x in the interval minus L to L. Minus L to L. So minus L to L, how to give the Fourier series expansion here? F of x is equal to a naught by 2 plus summation an cos n pi x by L plus bn sin n pi x by L. N pi x by L, and here the a naught, an and bn are called as a Euler constants or Fourier coefficients. Now this a naught can be given as 2 by L integral 0 to L f of x dx, and an value can be given as 2 by L integral 0 to L f of x into cos n pi x by L dx. This is n pi x by L into dx. Similarly, bn value can be given as 2 by L integral 0 to L f of x sin n pi x by L into dx. So these are the values. So this is how the both mostly c to c plus 2 pi and minus L 2 pi. In the intervals only this angle, cos angle or sine angle will be differing. Next question, 18th question. F of x is equal to x square minus 2, x square minus x is minus pi to pi. What is the value of a naught? What is the value of a naught? How to give the value of a naught? A naught is equal to 1 by pi integral minus pi to pi f of x dx. So what is f of x here? F of x is nothing but 1 by pi integral minus pi to pi. F of x is nothing but x square minus x into dx. Okay, so that is nothing but 1 by pi integral of x cube by 3 minus x square by 2. To that we will apply minus pi to pi. So applying minus pi to pi, and after getting this, we will get the a naught value. This is how we have to solve the 18th question of the Fourier series of part A. Now, going to the 19th question. 19th question, write the Fourier series for the even functions. The Fourier series for the even function is based on only two terms, that is a naught and an value. So, that is a naught by 2 summation an cos nx. And this is for Fourier series even function, and odd function that is based on bn sin nx. So these are about the part A questions of Fourier series expansions. Now going to the part B questions. Obtain the Fourier series expansion of f of x given that f of x is equal to pi minus x whole square in the interval x raises from 0 to 2 pi, and reduce the value of 1 by 1 square plus 1 by 2 square plus 1 by 3 square, so on up till pi square by 6. Now what is the interval 0 to 2 pi? Now what is a Fourier's expansion? What is the formula for Fourier expansion? F of x is equal to a naught by 2 plus summation an cos nx plus bn sin nx. Okay, so what is now what we need to do? We need to find out the three Fourier coefficient values, a naught, an and bn value. So a naught value, how to find out the a naught value? A naught value can be found by in the 1 by pi integral 0 to 2 pi f of x dx. What is f of x? Pi minus x whole square. Then what is the integral of pi minus x whole square? That is nothing but pi minus x whole cube by minus 1. So apply the upper and the lower limit, then simplify the answer. So that is how we can able to get the a naught value for the Fourier. Now still, what is the next coefficient that we need to find it out? EAN value. What is the formula for AN? 1 by pi integral 0 to 2 pi 0 to 2 pi f of x cos nx dx. What is f of x here? Pi minus x whole square. So integral of pi minus x whole square into cos nx, we need to find it out. How to find out this value? We can use the that is integration by parts. What is the formula? Integral of f into g. Again we have to use this integration by parts. All long answers bear these values, this formula, integration by parts, it becomes easy. So integral of f into g. What is integral of f into g? F into g1 minus f dash into g2 plus f double dash into g3, so on. So this is the integration by parts. So if you do the integrating by parts, for this, what are the answer that you are going to get here? Pi minus x whole square, integral of cos nx is sin nx by n, minus derivation of pi minus x whole square, that is 2 into pi minus x, internal differentiation is minus 1, into again the derivation of, again the integral of sin nx, that is nothing but minus cos nx by n square. One n is from the first term, second term we are getting one more n, so both clubbed together we will get n square. Okay, plus the derivation of the 2 into pi minus x, that is nothing but minus 2. So we are minus 2 into again the integral of again minus cos nx, that is minus sin nx by n cube. So all three terms will be there. First and last term you equate it to 0, because at 0 and 2 pi sin value is automatically become 0. So we need to find out only the second value. To second term itself, it's enough if you substitute upper and the lower limits. So upper limit is 2 pi and lower limit is 0. So apply the upper and the lower limits, we are going to get the EAN value. Similarly, you go for the BN value. What is the formula for BN? 1 by pi integral 0 to 2 pi f of x sin nx dx. Again, we use the same integrating by parts, that is integral of f into g. Integral of f into g is nothing but f g1 minus f dash g2 plus f double dash g3, so on. So here, what is f pi minus? That is a limited. The terms which have the limited derivatives has to be taken as f, and the terms which has continuous derivatives has to be taken as g. If you do the vice versa, then the integration is a never-ending process there. So we have to choose the terms in such a way that after 2 or 3 terms, the integration by parts should be ended. Otherwise, it becomes a problem. Now, in the similar way, using this formula, after finding Bn, you substitute in the main formula of the Fourier series, that is a0 by 2 plus summation an cos nx plus bn sin nx. So that is how we can do the expansion. Now, what about the deduction? After getting the expansion of pi minus x whole square in terms of s cos sine, in terms of Fourier series, you substitute x is equal to pi by 2. X is equal to pi by 2. So then we are going to get the deduction. For deduction, we need to assume the values of x. X has to be assumed either pi by 2 or pi by 3. Based on the deduction, the type of the deduction that he asked, we can choose the values either pi by 2 or 0, so on. So going to the next question. Find the Fourier series to represent the f function f of x is equal to mod sine nx and minus pi, x lies between minus pi to pi. Here also, the Fourier series expansion is given by, but the Fourier series expansion is given by a0 by 2 plus summation an cos nx plus bn sin nx. And in the interval minus pi to pi, the f of x is given as mod sine nx, which is an even function. So I think it's enough if you find out a0 and an value for the second question. And going to the third question. Find the Fourier series expansion of the function f of x is equal to x in the interval minus pi to pi. I think this problem we have already in the previous questions, minus pi to pi. F of x is equal to x. Yes, we have the 10th question. The Fourier, here we asked you to find out the Fourier coefficient A2, but here he is asking you to find out the complete Fourier series. So how to find out the Fourier series? Again, the same formula. A0, write the expansion and put the values of the Euler constants. One by one, we have to solve it. For an, a naught and bn value. Here, as the function is very easy, you can find out very easily the a naught value, that is 1 by pi integral minus pi to pi f of x dx. F of x is nothing but x. So what is integral of x? X square by 2. Integral of x is x square by 2. So from where to where we need to do the integration? Minus pi to pi. So minus pi to pi. So if you apply the limits, so we are going to get the a naught value. Similarly, bn value. Bn value. What is the bn value? In the 1 by pi integral minus pi to pi f of x cos and x dx. F of x is nothing but x. So you use the formula, same formula, integration by parts. X into integral of x into cos and x dx, that is x into sine nx by n minus 1 into minus cos and x by n square. So only two terms we are going to get in the by parts integration. In that we need to apply the upper and the lower limits. So we are going to get the an value also. Similarly, go for the bn value. What is the formula for bn value? So that is bn value is nothing but 1 by pi integral minus pi to pi f of x sine and x dx. So we need to substitute the formula f of x is equal to x. Put the value of f of x is equal to x. That is the functional value he has given. Then integrate integrate it by using integrating by parts from minus pi to pi. Then you can get the bn value. So a naught, an and bn, again three values have to be substituted in the Fourier series to get the Fourier expansion of the given function in terms of sine and cos. Now, fourth question is very much similar to that of the second question, here mod this is again a even function, and we'll be having only few Fourier coefficients that we need to find it out. So we have to check whether the function is even and odd function. By knowing that it is even and odd, half of the problem can be reduced. Next, find the Fourier series to represent the function f of x is equal to e power ax in the interval x rises from 0 to 2 pi. So what is the formula again? It's better to recapitulate the formula again and again. That is a naught by 2 plus summation an cos nx plus bn sin nx. So here, what is a naught? A naught is equal to 1 by pi integral 0 to 2 pi e power ax dx. What is the integral of e power ax? E power ax by a. Okay, from 0 to 2 pi. So what is the answer here? It is nothing but 1 by a e power 2 pi minus 1. So e power 2 pi minus 1. So that is how you can find out the Next, going to the an value, second Fourier coefficient. How to find out the second Fourier coefficient? Second Fourier coefficient can be found out by an is equal to integral of 1 by f of x into e power, that is f of x into cos nx. Here f of x is nothing but e power ax. So here integral of e power ax into cos nx, and this can be brought out by using reduction formulas, because both are continuously differentiable functions. E power ax is never in a reduction formula, and e power ax and cos nx are never ends their derivatives. They are continuously, they have the derivatives continuously. So if that is the case, we can make use of the reduction formula to get the integration. So what is the reduction formula? E power ax by a square plus n square into a cos nx plus b sin b. I mean, here n is there in place. A cos bx plus b sin bx. So this is the reduction formula, and apply limits from 0 to 2 pi to give the answer. So after getting the answer, this have to be substituted in the main Fourier series. Similarly, bn also. For bn, we will get the e power ax sin nx. Again, we use the reduction formula here. We use the same reduction formulas to two different types of formulas that we have already discussed in the previous sessions when we are referring this Fourier series. So after getting this, solving this by reduction formula, apply the limits and substitute in the Fourier series. Now going to the 7th question of the part B. Obtain the Fourier cosine series of the function f of x is equal to x sine x. X lies between 0 to pi, and show that 1 by 1.3 minus 1 by 3.5 plus 1 by 5.7 minus 1 by 7.9 so on is equal to pi minus 2 by 4. That is a question. Here the function itself he has given as a product of the two functions. So here x, what is f of x he has given x into sine x, x into sine x. Now we need to find out the Fourier. What is the Fourier coefficients? A0 by 2 plus summation an cos nx plus bn sin nx. So in that a0, an and bn are the three Fourier coefficients. We need to find it out in the interval 0 to pi, and after finding out that we have to take the deduction part. For deduction part we need to assume x is equal to pi by 2 or 0. Based on the deduction we can assume the values. So mostly here while doing the integration we are using the trigonometrical transformations, because we are going to get x into sin nx or x into sin x into cos nx. So we have to multiply and divide by 2, and we can make use of the formulas 2 sin A sin B and 2 sin A cos B formula. That is sin cos some cos difference and sin some sin difference. Then only the integration by parts becomes it can be split up. Again the two parts contains a product of two functions which can be done by integration of f into g. What I mean to say that here, suppose if you are solving an value, what you are going to get? X sin x cos nx. Right? These two have to be clubbed together by multiplying and dividing with 2 and using 2 sin A cos B formula, that is trigonometrical transformation, cos nx. Okay, that can be written as sin sum plus sin difference, sin sum plus sin difference. So after splitting up this in this model, in this way, multiply each and every term with x here, and then easily we can get it up. And this solving already we have done it in while doing the lecture in the previous sessions. Going to the next equation, 9th question, 8th question. 8th question and 7th question are same. Here in 7th question we have x sin x, and here instead of x sin x we have x cos x. Only there will be the change in the trigonometrical formulas that we are using, that is x cos x. Next, 9th question. If f of x is equal to cos hax, expand f of x as a Fourier series in the interval minus pi to pi. So cos hax, how to find out the you can write this as e power ax plus e power minus ax by 2 and split up into two parts, and easily we can do this for one, or otherwise directly also we can find it out cos hax. But directly means it becomes complicated. Better if we have to write in this form, and better we can find out the Fourier series. Now going to the 10th question. Find the Fourier sine and cosine series of the function 1 by 12 3x square minus 6x pi plus 2 pi square he has given. So here algebraic function is given in interval 0 to pi. So what is the Fourier expansion? Again you write the formula for the Fourier expansion. That is nothing but a0 by 2 plus summation an cos nx plus bn sin nx. So we need to find out the three Euler values, that is a0, an and bn value. So we can find out these three values to substitute in 0 and pi to get the Fourier sine and cosine series. And for specifically he asked about the sine and cosine series. So for cosine series we have only a0 and an value we need to find it out, and for sine series we need to find it out only bn value. So there is no need to write the total expansion. Only for cosine series 2 Fourier coefficients are enough, and for sine series 1 Fourier coefficient is enough to find it out. For the polynomial function, that is 1 by 12 into 3x square minus 6x pi plus 2 pi square. So going to the 11th question of the part B, express the function f of x as x minus pi as a Fourier series in the interval minus pi to pi. So how to express this as a Fourier series in the interval minus pi to pi? First, let us check whether it is even and odd. It is neither even nor odd. So we have to find out all the three Fourier coefficients, that is a naught, an and bn value. So what is the a naught, an and bn value? Already we have discussed how to find out the a naught, an and bn value. A naught is nothing but 1 by pi integral minus pi to pi f of x dx, and an is equal to 1 by pi integral minus pi to pi f of x cos nx dx, and sine bn is equal to 1 by pi integral minus pi to pi f of x sine nx dx, and we can find out the all the three Fourier coefficients, substitute in the expansion. Next question. Find 12th question from part B. Find Fourier series to represent the function f of x is equal to e power minus ax from x raises from minus pi to pi. Hence deduce that pi by sine h pi 2 into 1 by 2 square plus 1 minus 1 by 3 square plus 1 plus 1 by 4 square plus 1, so on. For getting the deduction, it is must and should we have to get the expansion first. First, we need to expand it. What is the function? E power minus x. Then what is the interval? Minus pi to pi. So, as usually, we need to find out the Euler's formulas and substitute in the Fourier expansion. After getting the expansion, we need to assume the values of x to get the deduction. Assumption is completely based on the type of the deduction that he has asked. That we have to assume it with what the value angle have to be substituted in order to get this type of deduction. So easily we can able to guess that deduction after getting the expansion only. Next, 13th question. Expand f of x is equal to pi minus x by 2 whole square as a Fourier series in the interval 0 to 2 pi, and deduct and hence deduce that 1 by 1 square minus 1 by 2 square plus 1 by 3 square minus 1 by 4 square, so on, is equal to pi square by 12. Pi square by 12. What is the function here is pi, that is pi minus x by 2 whole square here asked. F of x is equal to, in the interval, what is the interval here chosen? That is interval is 0 to 2 pi. So how to, what are the three Fourier coefficients we need to find it out here. All the three Fourier coefficients and Euler coefficients in the interval 0 to pi has to be found, and if possible we can use the integration by parts also and find out the Fourier series, because the function is somewhat, it's second degree function, that is pi minus x by 2. Mostly three terms we will get in the Fourier in the integration by parts, and apply the limits from 0 to 2 pi. And after getting the Fourier series, we can give the assumption to give the deduction part. So this is how we can discuss the 13th question. And going to the 14th question, find the Fourier series to represent f of x is equal to x minus x square in the interval minus pi to pi. This question is already done in the previous section, but still let us discuss how to do the problem. F of x is equal to x minus x square. So it is neither even nor odd. So we need to find out all the three for Euler constant, a naught, an and bn value. Only that there will be a change in interval. That is, what is the interval? Minus pi to pi. So a naught is equal to 1 by pi integral minus pi to pi f of x dx, and an is equal to 1 by pi integral minus pi to pi f of x cos nx dx, and bn is equal to 1 by pi integral minus pi to pi f of x sin nx dx. Use that formulas to get the required Fourier series. Now going to the 15th question, find the half range sine series. What is a half range sine series? Integral of bn sine nx. This is a half range sine series. So what is the bn value here? Bn is only coefficient, because a naught and an both will become 0 for the sine series, half range sine series. So you have only bn value. So how to get the bn value? 2 by pi integral 0 to pi f of x sin nx dx, sin nx dx. nx into dx. What is f of x? He has given this value, that is x into pi minus x square. So what you are going to get over 2 by pi integral 0 to pi x into pi minus x into sine nx dx. Again we can make use of integration by parts, that is integral of f into g, which is equal to f into g1 minus f dash into g2 plus so on. Again and again we are using the same integration by parts to get the integrals of this product of two different functions. So this is we can able to get a half range sine series. So after getting the half range sine series, we have to put the assumption x is equal to pi by 2 or x is equal to 0 to get the, based on the deduction we need to take the assumption part. Now going to the 16th question of the part B. Express f of x is equal to e power minus x as a Fourier series in the interval minus L to L. This is very similar to that of the previous question, that is we have done already. That is 12th question that we have done already. Instead of e power ax, he asked only e power minus x in the interval minus L to L. Minus L to L. So same as we have done in the previous case, that is we have found three Fourier coefficients a0, an and bn. Here also we need to find out all the three Fourier coefficients and substitute in the Fourier expansion. Now going to the 17th question, find the Fourier series of periodicity 3 of this is a question which is asked in the arbitrary interval 0 to 3. So here 2x minus x square is a function, and what is the a0 value? A0 value is 1 by 3. That is 1 by 3 by 2, because here b minus L is equal to b minus a by 2. B is 3. So 3 minus 0 by 2. So we are going to get a0 is equal to 1 by 3 by 2 integral 0 to L, that is 0 to 3, f of x, that is 2x minus x square dx. 2x minus x square dx, and an is equal to 1 by 3 by 2 integral 0 to 3 2x minus x square into cos n pi x by 3 dx. And what is the bn value for the 17th question? 1 by 3 by 2 integral 0 to 3 2x minus x square sine n pi x by 3 dx. So after finding these three values we have to substitute in the Fourier expansion. F of x is equal to a0 by 2 plus summation an cos nx plus bn sin nx. So this is how we can do the 17th question, that is 2x minus x square in the arbitrary interval 0 to 3. Now going to the 18th question, find the Fourier expansion of f of x is equal to pi square by 12 minus x square by 4 in the interval. This question is already done in the previous cases, that is we have already done this question, pi square by 12 in the previous case. So use the same. See, 8th question we have done. 8th question in the part A we have done the same question here. So here also we have to apply the same 8th question from part A. We can refer the 8th question from part A and find out the Euler's intervals and substitute in the Euler Fourier expansion. 19th question, half range cosine series. For half range cosine series, we need to find out only a0 and an value. Only bn value will be equal to 0 for half range cosine series, just like even function in the interval minus L to L. So we need to find out only a0 and an, only two Fourier coefficients here. Okay, so bn will be equal to 0 for the half range cosine series. Now half range sine series, only a0 and an both will become 0, but only bn value will exist. So bn value we need to find it out. So here a0 and an value we have to find out for the 19th question, and the 20th question we need to find out the only bn value, because he asked only the half range sine series. So this is how we can do the part B question. So going to the part C. What is the function here? F of x is equal to x. X lies between 0 to pi by 2, and pi minus x, x lies between pi by 2 to pi. Here he has given the discontinuous function, and he asked you to prove that 4 by pi is equal to sine x minus 1 by 3 sine 3x plus 1 by 5 square sine 5x, so on. So 1 by 3 square sine 3x plus 1 by 5 square sine 5x, so on. So here here it's a discontinuous function. So when you're integrating from minus pi, 0 to the intervals, the complete interval is 0 to pi, and that can be splitted up into two parts, that is 0 to pi by 2, 0 to pi by 2 plus pi by 2 to pi by 2 to pi. So two parts we need to find out. And from 0 to 2 pi, pi by 2, the functional value is x, and pi by 2 to pi, the functional value is pi minus x. So these are the terms we have to take while splitting up the interval, because this function is a discontinuous function we have he has given. And for deduction part, after getting completely the Fourier series, we have to assume a0, an, and bn values. So that is how the first question can be done. Even the second question is also the discontinuous function, that is from the total interval is minus pi to pi. So integrating from minus pi to pi have to be split up into two parts, minus pi to 0 and 0 to pi. So at 0 the discontinuity exists. At the point 0 the discontinuity is existed. So we have to cut the interval at the 0, and minus pi to 0 it is continuous, and again from 0 to pi it is continuous. Only the discontinuity is there at the 0 value. So that point we have to cut it. So at the minus pi to 0 the functional value is minus pi, and at 0 the functional value is x. So here you can give the integration of minus integration of pi dx plus integral 0 to pi x into dx. So this is how we can take the functional value. Going to the third question. The intensity of the alternating current after passing through the rectifier is given by I of x is equal to I0 sin x for x lies between 0 to pi, and 0 for x lies between pi to 2 pi. Even here also at pi the discontinuity is existed at pi. So the total interval is 0 to 2 pi, which has to be splitted up at 0 to pi and pi to 2 pi. Pi to 2 pi. We have to split it up into 2 pi. We have to split it up into two parts. And again, doing this, here also we need to find out all the three Fourier coefficients, a0, an, and bn value. And after finding out all the three Fourier coefficients by splitting up this integral, we need to substitute in the Fourier coefficients. And going to the fourth question is also similar to that of the above cases, that is discontinuous functions, that is 1 plus 2x by pi, and the discontinuity is there at x is equal to 0. X is equal to 0 is a discontinuous function. What is the total length of interval that he has asked? Minus pi to pi. So how to split it up? Minus pi to 0 and 0 to pi. Two parts we have to split it up now. And then in each part we have to put the respective functional value. What is the functional value in the first part? Minus pi to 0, the functional value is 1 plus 2x by pi into dx, plus in the second part, that is 0 to pi, the functional value is 1 minus 2x by pi. So in this way we can give the and he asks you to find out all the three Fourier coefficients, a0, an, and bn value, a0, an, and bn value. So for each and every, for finding out a0 also we have to split the integrals, and an and bn also we need to find out, split the integrals. For each one we need to take that integration by parts, integral of f into g, and go with the problem. So that is how we can find out the fourth question. And fifth question is similar to that of the fourth one, only he has split it up into three parts. What is the total length? Minus L to L. Minus L to L is divided into three parts. From in the first part, minus L to L by 2, he has minus L by 2, minus L to minus L by 2, and in the second part, minus L by 2 to L by 2, and the third part, L by 2 to L. So total minus minus L to L, it has to be split up into minus L to L by 2 plus L by 2 to minus L by 2 to plus L by 2, and the third part L by 2 to L. So 3 parts we need to work it out, the integration for this type of discontinuous form for A0, N and Bn. It's very lengthy problem. Next, obtain the Fourier series of the function. Here only constant is given, but the discontinuity is there at 0. So it becomes easy because the functional value is only constant, minus k and k. So from where to where the interval is minus pi to pi. At what point we need to cut it? Minus pi to 0 and 0 to pi. 2 parts we need to get it now. And in these 2 parts, we need to work out all the 3 Fourier coefficients. And after getting the expansion, we have to do the deduction part by assuming x is equal to pi by 2 or 0 based on the deduction, based on the type of the series that we have got. We can assume, comparing with the deduction, we can assume the x values. And going to the next, determine the Fourier series of the half wave rectifier signals. F of x is equal to sine t lies between 0 to pi, and pi to here. What is the discontinuity point? Pi. From where to where he has given 0 to 2 pi. So 0 to 2 pi have to be split up into 0 to pi and pi to 2 pi. So 2 parts we need to find it out. And in these 2 parts, half wave rectifier, that is all the 3 Fourier coefficients we need to find it. That is Euler constant and substitute. And going to the eighth one is very much similar to that of the fifth and fourth one. It's a discontinuous point, discontinuous function, and periodic signals with fundamental period t is equal to 2. Find the Fourier coefficients. He just asked you to find out the Fourier coefficient. There is no need to substitute and find out the total expansion. It's enough if you find out A0, An and Bn values. And ninth one, already this type of question previously we have done. That is pi minus x by 2 whole square. In previous session, in the previous question, that is some of the questions. Yes, 13th question from question bank. In the part B, we have done this question. That is pi minus x by 2 whole square. From the x lies between 0 to 2 pi. An and Bn, only 2 values he asked you to find out. There is no need to find out A0 value. Only you see the question properly, read the question properly. What the values he asked? Did he ask the total Fourier series, or did he ask only particular Fourier coefficient to bring? So based on that only you move. Otherwise, he asked one thing and we are doing the total thing, it goes off waste. Now, last question, obtain the Fourier series of the function f of x is equal to, again here the functional value, the total interval minus pi to pi, he has split it up into 3 parts. That is minus pi to this is 0, minus pi to 0, minus pi to 0, and 0 to pi by 2, and pi by 2 to pi. So what is the integration that we have to take? Minus pi to pi has to be split up into minus pi to 0. Minus pi to 0, what is the functional value? X. Plus 0 to pi by 2, what is the functional value? That is 0. So second term, there is no need to find it out. And third one, pi by 2 to pi, what is the functional value? X minus pi by 2. So this is how we can split up and find out all the 3 Fourier coefficients. So this is how the discussion of the question bank runs. And remember the formula properly, and based on the formula, based on the question and the deduction, after getting the expansion, what is the x value that we need to get? We need to assume the perfect value to get the deduction, and see whether it's half range or full range or even function or odd function. Based on that, few Fourier coefficients can be exempted, and only few. There is no need, you people have to find out only few Fourier coefficients. So that is how the question bank questions of part B, part C in the Fourier series can be done. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.